Now here's the good news. For the rest of the day, it's much more specific features that we have, and I think they're all a lot more cut and dry, clear. Oh, we have a security risk, brute force, here we have protection. And what's nice is this protection and this protection, this protection, this protection, this protection, they're all very easy to enable. Not a lot of difficulty. So we're just going to cover all of that. We're going to start with brute force protection. So we'll start off by talking about, as a review, if you're not familiar, what a brute force attack is. Brute force attacks typically target logon pages. The goal is to try to find somebody's credentials, typically using a data list of username password combinations, maybe in an Excel spreadsheet or some format like that. And then we use a script. And the script just sits there and tries to log in over and over again using something like macro, Firefox macro. Just keep trying to log in until maybe, if we're lucky at some point, look, I got a logon page. I'm logged on as Bob. I got on. I can see Bob's information. I see all of his money. Now I can get in and maybe I could add a new account for Bob, which is my hacker bank account. I could do a transfer. I could do whatever I want. So that's the main definition of a brute force attack. Typically, there's a couple of scenarios for trying to identify someone's credentials. Here at F5, we have very specific formats for our email addresses, for example. My email address, Salmon's, Kakyang's, everybody, if you look at our email address, they typically have the same format. I don't know if anybody's noticed it, if anybody's ever seen it. Has anybody seen the format of our email address at F5? If you have, I'm very impressed. It means you got a good eye.
Yes.
I'm sorry? What is that? So what is the C?
Your first name.
Not my first name. The C is the first initial dot my last name. So if I know that each one of us in here, our email is the first initial dot last name, then I have a pretty good guess of what my CEO's email address probably is, which might be their login address that they use to get into our services. So one format of a brute force attack is when I have a fairly good idea of what their username is. And then I'm going to use a very long string of thousands of possible passwords with that same email address. That's very common. The other, let's say I discover my CEO's password for F5. Now I know my CEO's F5 password. Odds are, studies have shown, that that's probably the same password he uses for all of his personal stuff, his online banking, his Facebook, everything else. But it's probably not the same email address. For that, he probably has his own user ID, his own personal user ID. Studies have also shown that most of us, when you think of your own personal user ID that you use to log into your online banking, your Facebook, and so forth, think of your ID, your user ID. Studies have shown that most people's user ID typically utilize one very common aspect about themselves. What aspect is that?
Your name?
Their name. Think about your own username. And does it include some form of your first name, your middle name, your last name? If not, good for you. That means you're going to be harder to brute force. Unfortunately, mine is, because I've had the same username for like 20 years. And I don't want to change it. I should, probably. So now, if I know my CEO's F5 password, and I know his name, now I can just trying to go to bankofamerica.com, wellsfargo.com. I'll go to every bank out there, and I create a data list using the password I know is probably the right password, with thousands of combinations of this person's name. So I'm going to target different usernames. That's a second kind of a brute force. So one, I'm just trying one user ID with lots of passwords. Another is I'm trying lots of user IDs with the same or different passwords. So in order to set this up for protection, if we want to protect this, there are two things we're going to set up in the BIG-IP. The first is called a logon page element. We need this because we need to know what page they're using to log on. We have to know that. So there's four things we need to know about this page. We need to know the actual URL. We need to know the parameters, the parameter names that they're using to enter this information. Online ID 1, passcode 2. We also need to know the difference between a successful login and a failed login. And you can tell that just by performing a failed login and look at what is returned to users who have a failed login. There's some very specific text that only people with a failed login are going to see. Likewise, when I have a successful login, there's text that only people with a successful login are going to see. So those are the four pieces of information we'll want when we go into BIG-IP to create the login page element. On login page list, we click on create. By the way, when you're using comprehensive template, it is designed to recognize these login pages for you after a period of time when users are logging in. It'll actually recognize what your login page is and the parameters and all that. Unfortunately, we don't have time. We guys got to get right to it. So we're going to create our own. So you'll start by specifying that login URL, username parameter, password parameter, and text that appears on successful logins, text that appears on unsuccessful logins. That's all we need to do. The cool thing about this item here that we just created is this item is not just used for brute force protection. We can use this for a variety of things. But most importantly, what we can do, once I have a login page element, I can now see every user that logs into through ASM. When I'm looking at the log files, I can see every successful login, every unsuccessful login, and the username of each. We can get that. So even if we're not doing brute force protection, we can still utilize this for some good visibility. The second step is just to go and configure the protection itself. So we have a section called anomaly detection, which just has two items, web scraping, brute force. Under brute force, we have this default item. This default item, you're probably never going to use. The idea here is if there are multiple logon page elements, multiple logon pages for this website, these settings apply to all of them. I'm not going to use that. I'm going to create my own specific settings for the logon page I just created. So I click on create. We're going to first specify the logon page element that we just created. If there are groups of locations, like we're doing testing, we're doing some sort of a load testing or performance testing from this group of IP addresses, we don't want to block them, we could whitelist those. And then we have source-based brute force protection, and then down here distributed. We're going to focus, and you guys, this courseware focuses on source-based. In my upcoming ASM class, that'll be up to 3 days, we'll cover this. And this is a bit more of the advanced WAF side, AWAF. Right now my slides still are going to show a little bit of this, but I'm going to change these slides and update them so that you don't have this call out here. I don't want you to cover too much in this lesson, more than you need to. So we're going to focus on source-based. So The first thing was source-based. We have two time values here. How we detect an attack in progress is going to be based on so many failed login attempts from something. So many failed login attempts, and the amount of time we will look to see if so many failed login attempts have occurred is the detection period. So right now, for example, you see one of these is 3 failed login attempts. Then we're going to think there's a brute force attack. But if that person waited more than 60 minutes for all 3, it wouldn't detect it. Then you got the maximum prevention duration. So for each of our detection options, they each have a separate mitigation, which is a big improvement we've made, huge improvements we've made to brute force protection. Big improvements. One of those improvements is that we have several ways to identify brute force attacks, and each one of them can have its own mitigation. How long somebody's under mitigation is this value. So these are the different methods that we can use to identify brute force attacks from a source, a single source. Distributed implies several sources. Username. This means they're targeting the same user ID. So I'm trying to figure out my director's password by using the same user ID and just a ton of passwords. We can quickly identify that. Device ID and IP address are very similar. They're very similar. IP address is very specific about this computer. Device ID may change based on browsers I'm using and so forth. But something about my computer. So for each one of these 3, I can specify the threshold. How many failed logins? And remember, we can identify when it's failed because of that text we put on the logon page element. We know when they failed to log on. So how many failed logon attempts does it take before we've identified this source is a brute force attacker? And then for each one of these, we can specify the mitigation. And we actually have several mitigations now. I'm only showing you 3. There are actually a couple of others. We can do an alarming CAPTCHA. So this is actually a really good example of why I might do one versus the other. We all make mistakes with our password. Fingers, fat fingers, caps lock. We don't want to just assume because they've had 3 failed logon attempts that they're trying to brute force. So if we just block them right from the get-go, that's a little harsh. So we can just give them a CAPTCHA challenge. You all hopefully know, I'll show you what that looks like if you're not familiar with the CAPTCHA challenge. I'm sure most of you are. And that way they just identify, yeah, I'm a human. I'm a real person. I'm just making a mistake. We can also issue them the standard ASM blocking page. We can also do a true drop, very much like a firewall drop, where they're just dead. Their page is dead and they don't even know why it's dead. They get no response whatsoever. And then this is also really fun. Just really cool improvements. I think this is very exciting stuff. So it is possible to have a script, a tool set up so that it can, and I've actually heard this blows my mind, that there are I don't want to say agencies out there, there are systems out there that can be employed to do CAPTCHA challenges for brute force attacks. Literally, people out there that are entering CAPTCHA challenges for attackers, and they're getting paid. And so it's possible that I could issue my 3 failed login attempts and get my CAPTCHA challenge. All right, I'll enter the CAPTCHA challenge, try 3 more usernames and passwords, get the CAPTCHA challenge, enter it again, and just keep doing that over and over again. So this is the CAPTCHA bypass mitigation. What that says is after so many CAPTCHA, successful CAPTCHA entries, now we're still in an attack situation, and we can do any other of our mitigations. We could block them again, we could drop them, but this is another mitigation, and this is actually a really fun one. So think about this. I think this is really fun. We can create a honeypot page. The honeypot page can be designed in any HTML format, so you can literally create a copy of the login page as your honeypot page. So after 5 CAPTCHA entries, they'll come back to the login page, just keep trying, or use their script to keep trying to do brute force, and they'll no longer get CAPTCHA challenges. It'll just be running the script, but it's not running it on the logon page anymore. It's running it on the honeypot page, and they have no idea because you made the honeypot page look like the logon page. Very clever. I think that's actually really fun. You're going to do a couple of these in the exercise. I don't have this in the exercise, but I am going to create a demo that you can look at that will show this as well. Really, it is a fun feature. I enjoy it. So again, don't worry about these. I'll cover these in a future class coming up soon, very soon. So here's what it looks like when they have a couple of these circumstances. So we now have the protection built in. We're now trying to log in as Bob, or as, Bob. We know Bob's username is Bob, so we're trying all these different passwords, and there's our CAPTCHA challenge. We can customize this CAPTCHA challenge a little bit, the text on it. Between you and I hate this CAPTCHA challenge because I would say at least 50% of the time, I don't pass it the first time. I don't get the letters in there and the numbers correctly. It is case sensitive. It makes me crazy. They can try to submit it, and then they're brought back here. They can continue to try to log in. No problem. We see great visibility in the event log. Our event log always has great visibility. But now I can see we had an illegal request. It's illegal because it wasn't blocked. Illegal. Brute force. The mitigation was CAPTCHA. The username was Bob. And they tried 4 times when the threshold was only 3. A lot of visibility. Now they're going to try different usernames of Bob. So not the same username. Robert. So it's not going to capture that username mitigation. It's going to skip that, but it will eventually catch the IP-based or device ID protection, which is blocking page. Now what's interesting is if they close their browser and they go into their browser again, try to log in, they're going to get immediately blocked. For how long are they going to keep getting blocked?
60 minutes.
The what? 60 minutes by default, which is that maximum duration, which can be configured. You can change that. Immediately blocked. And again, visibility. We can see that it's a blocking page. We see the device ID that submitted it, how many attempts were made, and so forth. This is something I'm taking out because this is part of Advanced WAF distributed. This is more part of distributed brute force and credential stuffing, which is going to be covered in a different module. So you won't see this slide, but this is actually some really cool stuff. But you guys won't be covering that, so I'm going to pass through that. So that's our brute force protection. It really is very easy to configure and works very well. Web scraping. Web scraping is a tactic that users use. I want to see the web page. There's the web page. I can just browse the web page. Let's say my web page has a bunch of airline statistics, all the flights that are coming up. I can just refresh my page as often as I want, and I'm always going to see the most current flight information. If I want, I could copy all that data and put it into some sort of a database. Web scraping does that with typically a bot, some sort of a automated script that just continues to scrape and floods, fills a table or a database of some sort with all this information. More often than not, it's just a single source though. It's usually several sources, like all the different airline websites. So I can scrape all the airline information, and then I can put that on my website to show very current data as of the last couple of minutes, however long ago it took me to scrape this. So my website could be based on my database, which is based on all the data I just scraped from all of them. Sometimes web scraping is what we want. Sometimes we want our website to be scraped. What's an example of a source that we would want to scrape our website?
Google. Yeah. Is it Google?
Which one?
Google.
Like Google. Do you want your website to come up in Google responses? The only way that's going to happen is if Google knows what's on all of your pages. So Google scrapes all the sites to get all the keywords and stuff. Well, we want that. So we have the ability to pick and choose. So here's an example. This is a very ugly looking web page, but it is a web page. It has all these news stories. And it's scraped. And then when it's scraped, it's put into a table format that could be like in an Excel file of some sort. And it's all the data that was on the page in column and row format. And once I have this in my Excel spreadsheet, it's my data. I can do whatever I want with it. So the way that we set this up, there's about 2 or 3 different ways to do the detection. How do I know it's happening? We focus on one in the class, the simplest to set up. It is all on the web scrape, the anomaly detection, web scraping. These are the different methods: bot detection, session opening, session transaction. Those are really the 3 main methods. We focus mainly on bot detection. That's what the exercise does. So we can turn that on. You can either just alarm, so you can see in the event log when you're being scraped, or you can alarm and block, which I think is self-explanatory. And then down at the bottom, we have the settings. Now, more often than not, in real production environments, these settings are going to be fine. I'm not going to go over what each one of these means, but the idea here is how many refreshes. I'm going to sit here and refresh, continually refresh. How many refreshes do we consider okay over a period of time before we really think something is up? How much time do I want to give them? So there's a grace period and so forth. These are pretty good values for a production system. We have to drastically lower these in our lab environment because we can't generate this much traffic in Ravello. So you're going to play with that, just lower some of these values so that you'll see a web scraping attack in progress. But there are a couple of other options. I don't cover these thoroughly. I don't recommend you cover them thoroughly. But session opening, detecting just a bunch of new open sessions versus kind of refreshes, page refreshes. This is just done on new sessions being opened from the same client IP address. And you can do things like a client-side check. That's like a JavaScript check, a JavaScript challenge, to make sure it's actually a client that can respond, so forth. And then session transaction anomaly. It's just a transactions per second value. How many maximum? Is it going up from one client? You could turn all 3 on and play with it and see how what it's blocking. That's the key. Watch what it's blocking. So that is that lesson. In the exercise, you will do 2 kinds of brute force attacks. They're both against me. So thank you very much ahead of time for trying to brute force me. Appreciate it. In one case, you are trying to attack my email address account because you know what it is. And you're going to use multiple passwords to try to do that. Then you're going to, once you find out Then you're going to try to find out what my personal user account is using combinations of my first and last name with the same password. We have to use a couple forms of brute force protection to catch both of those. And then you will do a very basic web scraping attack using an iMacro, Firefox, and then you'll block it. So I've got an hour allocated for this. Right now it is 2:25. That should take us to about 2:35. Should be more than enough time for this.